In this video tutorial in Unreal Engine, we're going to take a look at how we can make some realistic looking fur. We'll be able to grow this fur out of any object, and it won't require any plugins or any special hair setups. It'll all be done through the material and a blueprint. We can also tile that fur to give it a lot more detail and get a pretty good looking result. This will all be done through a method called shell texturing. We can also have controls for root and tip color. So we'll be able to vary the tint of the hairs from the root to the very end at the tip. So if I were to select something like red and blue, we could see that the root starts at red and tapers to blue as it reaches the end of the fur. So the whole idea of shell texturing is you can have a surface, like in this case, this flat plane, and then have something like a texture on it that uses opacity or alpha to cut out details. Now the idea of shell texturing is we could duplicate this mesh, and as you can see, if I move it upwards just a little bit and make many duplicates, it starts to make structures that somewhat can seem almost 3D. But it's really just a bunch of flat planes or flat surfaces duplicated outwards. This is kind of the approach behind this shell texturing method for hair, but we're going to do it in a little bit more elegant way where it's not as manual. I'm going to start off with a brand new scene, and the very first thing that we want to do is create this geometry. So we're going to do a blueprint that will automatically create the shells for us. So we'll create a blueprint class, I'll make it an actor, and I'll call it something like BP underscore shell texturing. Once we've done that, we can open up our blueprint, and the very first thing that I'm going to do is go over here to the components and add a static mesh. This will be the mesh that will create our object, in this case maybe the cat or the creature or whatever we have that we're adding fur to. And then we're going to want to create a variable that references the asset, because really we want to be able to reuse this blueprint and just drop in different meshes, one for a teddy bear, one for a cat, one for a rug. We want to be able to reuse it and not make it a hard coded in. So we're going to add a variable. That variable we're going to call input mesh ref, and I'm going to make it a static mesh, but we're going to make it a object reference. And then we're going to turn on this little eyeball so this variable can be changed from outside this node network and from outside being inside this blueprint. Like we'll be able to actually change that mesh if we have instances of this blueprint in our scene. Next, I'll jump over to our construction script because we want it to only create these shells once. Once when the game begins, or once when this object gets kind of placed. We don't want to have it recreating the shells of the geometry constantly. That should only happen once. So the construction script will allow us to do that. We'll drag out this pin and we'll do a set static mesh. And this is just going to be to set our static mesh here to whatever we have as our input mesh reference. So what we're going to do is our target will be our static mesh. Or maybe to name this a little bit better, instead of static mesh, I could make it something like input mesh. And then the mesh that we're changing that mesh to is our input mesh reference, the one that's exposed. And it will use whatever mesh is selected there and change the mesh here. So that will set our mesh for the main object. And we can set a default value for that. If we click on this input mesh ref, and we open up our sidebar here, we'll have to compile the blueprint first, but then we can select like a placeholder. And maybe for now, I'll do something like a sphere. So maybe I can just look up static mesh sphere. That might be a good placeholder for now, and I'll save that. We also have to determine how many shells we want to create. So let's add one more variable. I'll call this something like shell count. I'll make it an integer, so it's only whole numbers and no decimal places. You can't have half a shell. And I'll also make sure that that variable is public as well. And then I'll compile that, and I'll start off with maybe like 8 shells or something, or 10 shells as like the default setting. Maybe that's even a little bit high, but that's probably fine for now. And then what we have to do is take that shell count, do a loop. So we're going to go in here, add another node. We'll do something like a for loop, and we're going to loop from 0 to however many shells that we have, and it's going to execute whatever's in this loop body that many times. And what we can do over that duration is add a static mesh Now, technically, we could make this instant static mesh, might be a little bit more efficient, but I'll let you make those changes if you're needing to do that. But this is just like a rough idea of what we can do. So we can add a static mesh component, and then we have to set that static mesh component. So we'll do set static mesh. And what mesh are we setting? We're setting our added static mesh. So the target is our return value of our add static mesh. And the new mesh that we want to set it to is our input mesh reference, the mesh that we've selected in our blueprint slot here for this input mesh. And that's pretty much it. And that should just, loop through the shell count and add this object or add static meshes with that same mesh a bunch of times. The problem is we have to push that mesh outwards, so they're not all overlapping each other at the same space. Now, you might just think, okay, well, you could just do this by taking this transform here and, scaling it up. Just split this and do something like take the scale and make it our index. So as our duplicates increase, the scale just gets bigger. And in theory, that's kind of doing what we want. Like, here's that ball as a placeholder. And if we look at the wireframe, well, that's great. It's making all these shells. You could see all these duplicates of the mesh going outwards in the wireframe. And that works with a ball. But if you have something more complex, like a character or a creature or an object that's a little bit more complex shaped, you can't just scale it up to make a proper shell of it. That's not going to work. And maybe as an example of that, if I were to go back to lit mode or shaded mode, and I go in here to my input mesh reference, let's say I go in here and add the cat model. Look what it does. It's scaling from its pivot point outwards, and it's not really making a proper shell. It's kind of making like a very weird duplicate of it, just scaled from a single point. So it's not going to work for making proper shells by just scaling. So maybe I'll leave this cat as our sample model for now. And under the construction script, I'm not going to use this relative transform scale. What we're going to do, and there's probably a bunch of ways you could do this in blueprints, but I think it's going to be a lot easier to push the mesh outwards on each of the instances or on each of those added static meshes by doing it through the material. So that's what we're going to be doing. So what I'm going to do next is minimize this. We're going to go into our content browser, create a new material, call it something like m_shell texturing, and we're going to open up that material. And in our material, we're going to go here to our material here. We're going to take the world position offset. And the idea is we're going to have a variable that we're going to edit in our blueprint or make like an instance of and change. And we'll maybe call that shell layer. So I'll create a constant. I'll convert it to a parameter, call it shell layer. And this value is going to increase every time a shell gets made. And we're going to multiply that value by the vertex normals in world space of that mesh. And that's going to push the surface out along its vertex normals. And by doing that, it'll produce a proper shell. So that's going to be my material for now. Shell layer, which is a parameter multiplied by vertex normal world space in our world position offset. And we're going to save that. We can now go back to our blueprint, back to our construction script. After we set our static mesh, I'm going to create a dynamic material instance. The thing that we're creating that dynamic material instance on is going to be our added static mesh. So we'll connect that for the target. The material we're going to be instancing could be that m_shell texturing shader. And then what we're going to do is set scalar parameter value on materials. And again, the material that we're setting it on, or the target, is going to be our added static mesh component. And maybe let's move these so we could see those lines properly. And what is our parameter name? You have to make sure that name is spelled exactly the same. So I spelled it as shell layer with capitals for shell and layer for the first letters of those. And the value that we're going to use to push outwards, for now we'll just set it to our index just to make sure it works. So as it makes duplicates, the index goes up and it pipes that number into the shell layer and it pushes the vertexes out along the vertex normals. And if we compile this and save this and view this in our viewport, what do we got now? We got like this fat cat. And if we look at the wireframe, it's creating all those shells beautifully. And if we were to change our shell count, maybe like only 3 shells. Now there's only 3 shells, 10 shells, 100 shells. It's going to break it because it's pushing it too far out. You don't need that many. So maybe one other thing that would be useful for this is having a control to determine how far the shells are apart. Right now, they're just one unit pushed outwards every single time a new mesh is made. Maybe we want to have a little bit finer control over how far the distance is in between each shell. So to do that, I'll jump back to my material. I'll take shell layer. I'll make another constant. This time I'll make it a parameter and call it something like shell distance. I'll give it a default value of 0.1. We'll multiply our shell layer by our shell distance and then multiply that by our vertex normal. So something like that will give us a little bit of control with this shell distance parameter to determine how far spaced those shells are from each other. And we can save that. And after we're to change that, it's going to change the distance between the shells. So now you can see it's a lot more tighter packed. The shells are much closer together. Maybe if I zoom in really close here, we can kind of see that wireframe. So now we have a control for that, which is going to be very helpful. And one more thing we should do is make sure that these meshes that we're creating get attached to the original mesh. That way, if we have physics enabled and it gets pushed around, those other added static meshes don't get left behind. So to do that, we're going to go to our end of our construction script here, and we're going to add one last thing. We're going to add a attach component to component. Our target, again, is going to be our added static mesh component. Actually, yep, that's correct, our added static mesh component. And the parent is going to be our input mesh. So we'll drag in our input mesh here and make that our parent. And that way it's going to attach all those created static meshes to that original input mesh. So they go along with it and they move with it. And we'll compile and save that. Next, we have to properly create a material for this. So I'm going to go back to our M shell texturing material. And before doing that, maybe I'll just drag and drop this mesh in here. That's our mesh with all the shells. If we view the wireframe, you can kind of see all the shells there. Some duplicates of them. Actually, I don't know if it'll show. There it is. There's all the shells. So just to test this to make sure we haven't done anything wrong, I'm going to move that cat into the air. I'll go onto that input mesh, simulate physics, and just give it a quick simulate. And there we go. We can see that it all properly moves around, so it's not like being left behind. All those shells are moving with the final mesh. So next, I'll go back into the material, and we'll properly make our material for this shell texturing first. So we have our shell texturing material here, and to start off with it, most of this we're going to do through a custom node and some HLSL. So we'll create a custom node. We have an output for that custom node. We're going to have to add some things. We're going to have to add some additional outputs. So we're going to make a secondary output for out alpha, so we can output the opacity and then output the color. The return will go to base color. The out alpha will go to opacity or opacity mask. We'll start off just doing a masked material. You could use this with masked materials where it's either solid or transparent, or you can also use a translucent blend mode as well. Either one will work with the material that we're creating. We'll just give slightly different looks. But we'll start with masked material. We'll connect that up, and we're going to have to write some code in here. But let's keep this really simple at first. So I just need to create basic inputs. Like we need to be able to get the UV coordinates. So maybe the first input that we have here, I'll set to UV and connect that to our texture coordinates node. And then maybe the secondary input that we'll have, I'll add another input. I'll do something like UV scale, so we could tile the pattern. And I'll drag that out to a constant, make that a parameter, call it something like UV scale, and give it a default value of maybe 3 or something. And then on the custom node, I'll add another input. This input's going to be for our fur color, so we can load in a texture map for color, and another input for our fur texture, or like the pattern that's going to make up the fur. And once we have those created, we're going to create texture, not texture samples, but texture objects. You could technically create a texture sample and then right click and turn it into a texture object, but we'll do that for fur color. Again, texture object for fur texture, and we'll make these parameters as well, so we could change them in our instanced material. And we'll call this something like fur color, and then we'll call this one convert to parameter, and we'll call it fur texture. And we probably want to put some placeholder textures in here as well, so it starts off with something that actually works for the fur. So I'm going to take our fur color and I'll just make it have like a generic white material. And for the fur texture, I'm going to go in there and make it a fur pattern texture that I have here that you can find on the Patreon. If you're part of the Patreon, you'll get access to all the texture maps that I use. So now we'll write some of our code for our custom node. I'm going to go into Visual Studio Code and write this just so it's a bit easier for everyone to see. And I'm just going to start off with a float2. It's going to be our UVs. We're going to make a variable called fur UV, as it's going to equal our UV coordinates times by our UV scale. So we can tile the UVs, and that will be our fur UV. And then I'll make another float3, which will be like a color. This is going to be our outputted color for the fur, and we'll just make that equal a texture 2D sample fur color. That's our texture object that we created that loads in whatever texture we have there, and we'll just make that follow the UVs. And then we'll do a similar thing for our fur pattern, but that just needs to be a float because it's going to be most likely a black and white texture. Like, we're not going to care about color for that. It's more of just a black and white mask to make the cutout of the fur. And we'll call that, same thing, we're going to be loading a texture, and that'll be referencing our fur texture object. So I think we called it fur texture. Let me check. Fur texture, yeah. And we have to put fur texture sampler, and then this one will be our modified UVs, so we can tile it. So it'll be our fur UV that we use. And then we just care about the red channel, really, so we could just do .r. So it's just using a single channel. Maybe also useful if you had like different furs stored, different fur patterns stored in the same texture. You can have a different pattern in red, green, and blue, and reuse that same texture with just different channels or something if you wanted to, or if you wanted to do something more complex. Yeah, you don't have to have a color map if you just want to pull mask values. And then finally, at the very end here, we're going to output our alpha. Our alpha is going to equal our fur texture pattern, that black and white cutout, and we'll return our color as our default output value for our custom node. So if we put that code in here, you know, color is being outputted in our return value to base color, and our fur texture pattern, that kind of black and white opacity map, is being outputted by our out alpha here. And let's check if we get any errors. Like, you see, you get an error here called, it says fur texture has a problem here. And if I take a look at this line of code, we can maybe see what I've done wrong. Fur texture sampler, it's very easy to, you know, if you misspell something, like here I forgot the T, it says texture, should be texture. There we go, it solves all our errors, and there's our result. So just be very careful with spelling as well. It's very easy to miss something, and the error might not might not make much sense at a first glance, and you just need to check over your spelling. So to make sure this works, let's save this whole thing and let's try it out on our actual blueprint. So I'm going to go here to our blueprint, make sure it's all connected up. Let's view the viewport here. There it is. Okay, so that's working with that pattern. You can see it's creating the shells and it's pushing outwards, and it's not a bad start. And if we were to save this, and let me just put the blueprint in our actual scene right now. And maybe what we should do is create an instance of our material. So M shell texturing instance. And we'll use that in our blueprint. That way, what's going to happen is if I were to change these values, I'm going to see it update. So I have my UV scale 10, 5, 1. You know, we can change the tiling here and see like an instant update. You can see at like 20 tiling. It's pretty detailed fur. So already we're getting a pretty great result, and we've just started making this. Now this doesn't have the greatest lighting, so let's improve the lighting. I'm going to go back to the code we had here, make sure everything's all fixed up here. And we're going to add a little bit of code that will calculate some simple shading. It'll be like a modified version of Lambert shading, where we can have a little bit more control over the shadows and the highlights. So to do that, I'm going to make a float called n.l, and we're going to do saturate dot, and we're going to normalize normal, and then normalize our light direction. Now we're going to have to create these variables to get our light direction, to get our normal, and once we do that, this is going to give us a little bit better lighting. And to get that lighting into our result, into our color, we're going to take our color, multiply it by our texture, so our cutout, and then also multiply it by a couple controls. We're going to do a light offset, a light scale, multiplied by our n.l. And if we take that code, we paste it into our material, and I have to create all these inputs. So input for normal, input for light direction, input for light offset and light scale. So 1, 2, 3, 4 extra variables, and I'll put those in. Normal, light direction, or light dir, and then light offset and light scale. Okay, let's give us some room here, so I'm going to move this all up. And we have to create those connections, so we'll start with the easy ones. Constant as a parameter for light scale, and I'll make that 0.5 as a default. And then also a constant converted to a parameter called light offset. Also make it a value of 0.5. And then light direction, we have to get the direction of our lighting. You could specify this as like a position in 3D space, but I think an easy way to just get like the skylight direction is we could do a sky atmosphere light direction node. Just plug that into light direction. And then finally get our vertex normals in world space as our normal. We should be able to save that. The whole n.l calculation that we just added, like to explain it really simply, it's really just pretty much a calculation to determine what parts of that surface face the light source. So based on that, we can determine its brightness, and parts that don't face the light source, we can determine how dark they should be. So it's a very simple lighting calculation. So looking at what this does now, if I save this material, make sure it's all updated, we get a little bit better shading. And if we were to take our sunlight source and just like, angle it, rotate it around, not too bad. And one thing that you might want to do as well is in our material, on our main material node here, scroll on down in here and you'll find a section, maybe not too important right now since we're using opacity mask, but if you were to use translucent shading, one thing that will affect how it shades would be this lighting mode here. And by default is volumetric non-directional. By changing that, it's going to modify how the light interacts with the surface. So if you were using something other than masked blend mode like translucent for this, it might be worth adjusting that a bit. Now let's go into that in a little bit more. Maybe, this masked mode for the fur looks pretty good. And I actually like its look for a lot of cases. But sometimes you might want a little bit more transparency to the fur. So you might want to use a different blend mode. So if we were to change this to, say, translucent and save, and then we'll have to connect up our opacity to out alpha instead of opacity mask, you're going to see the fur looks a little bit different. And in some cases, it doesn't look as good. And you could make this look a lot better by having the fur kind of taper as it gets away from the root. Kind of have it fade off a little bit more. And that will help solve some of these edges and the look that we're getting right now. So maybe that's something we can do. And maybe we can test this out with a different texture as well. Like I'll take my instanced material here. You could start playing around some of these settings we have. Like we have shell distance. You could change that and push the fur out more or keep it closer. So there's already a lot of control that we have. And, light offset, the calculation we just added, you can make the shadow areas darker or brighter, or the brighter areas brighter or darker. So you have a lot of control already, and even fur color we can change. So if I were to go here and change the fur color to something like colored fur, already we're able to give it a tint as well, or like different colors on that fur. So we have a lot of good control here, but we can improve this a little bit more. And we're gonna use the value that we're getting from our blueprint to fade off these shells as they go outwards when used with this translucent mode. So what I'm going to do is go back to our code here in Visual Studio Code for now, and we're going to modify this code a little bit. We're going to add a section where we're going to be able to change the mask of that fur to become a little bit more transparent as it reaches the last shell. So I'll do that by making a new float called fur mask, and it's going to equal saturate. So we clamp between 0, 1 values. We'll do 1.0 minus our layer multiplied by our shell distance divided by max length. And max length will be a parameter that we can add that can adjust the tapering. And that will be the thing that is able to take our layer. And we'll have to connect our layer variable that we're going to have to make to those layers in our blueprint, or into the variable that controls the shell layering. And we'll use all that, and we're going to multiply it by our out alpha here. So we'll do fur mask multiplied by our texture. We'll take all this, throw this into our material. Have to add those attributes. So our shell layer here, we're going to reuse as our layer. So I'm going to create a new variable input called layer. And that's just going to go to our shell layer. And then we'll also have to create a input for our max length control. So max length, and I can make that equal, or just connect up to a parameter called max length. Just give it a default of like 1 for now, or 10. And then shell distance, that will have to connect to our shell distance here. So we'll need one more input, and we'll call that shell distance and connect that to our shell distance. And save. Take a look at this in our viewport. Open up our instanced material. Let's see if this works. So max length, 1, 2, 3, 4, 5. It's like 8, 10. So you can see how at the edges, let's just zoom into an area here. It's like that. And if we lower this, fades off sooner. And has like a nice gradual fade. And if the shells are too spread out, like I could see the separation in between them, maybe our shell distance needs to be a little bit more compact. Or maybe we need more shells, right? Like we can adjust these things through our blueprint and through our material here. So we kind of have another way to shade our fur now in like a translucent mode or in our masked mode, and we get a little bit different looks. Now, one last thing, what if we want to add some tapering? So my fur texture here, what if I put in like a gradient circle? And I know this is going to look a little bit odd. I'll have to tile it a bit more as well so we could see this. Let's go up and take a look at some of these shell hairs. So you can see they're all the same size right to the very end. What if we want to have some taper so they get sharper at the tip, or they get smaller at the tip and the root is thicker than the end of the hair? We can add a control to do that. If we have a gradient on our pattern, we can eat away from that gradient and shrink the alpha as the shells increase. And the way that we're going to do this, I'll go back to my code here. We're going to make a variable called float tip. And it's going to be saturate, so clamp between 0 and 1. We'll take our texture, and we're going to multiply it by a variable that we'll expose called fur tip, and we'll minus our layer. And we'll take that and add it down here. So we'll just multiply by tip. And if we do something like that, and we go into our material, and we paste it in here for our updated code, and we add that variable that we need a variable called fur tip to control it. So I add another input. I go down here, I give it a name, fur tip, and connect it to another constant. Right click, convert to parameter, fur tip, make it 10 or something, or 1. Actually, it would be better. And save that. Let's go see if this works. In theory, this should work, but maybe I've made a mistake or something. But let's see. So we have our values here. So for tip, okay. So 1 is too short. Let's try 10. See how it's like a cone now? If I make it 100, it stays the same as it was before. But if I do something like 50 or maybe 20, you can start seeing it shrink towards the tip. 10, 8. If you go too low, it cuts off too quickly. But now we can actually taper the shape at the end, which is really cool. Hopefully that gives you some good ideas for your projects if you just need a very simple hair or fur for some sort of props in your scene. If you enjoyed this video or you learned something new, make sure to like, subscribe, and if you're part of the Patreon, which you can find a link to down in the description below, you'll get the PDF for this video, which goes over all these steps in a little bit more detail, as well as additional steps to add root and tip color for the fur and some additional things as well. So if you're part of the Patreon, you'll get access to PDFs for pretty much every single video that gets thrown onto the YouTube. And you'll get a lot of extra information in those PDFs. And comment down below. Tell me where you would find this useful in your scenes or in a game. And also let me know what other kinds of tutorials or videos you'd also like to see.